Hello guys, welcome to Analytical Sphere. Today we are going to look at data cleaning in R and how you can generally handle a given data set, how you can clean it and make it ready for analysis. Data cleaning involves various steps, as from the initial raw data have to move toward the consistent and highly efficient data which is ready to be implemented as per the requirements, and produces highly precise and accurate statistical results. So the steps vary from data to data, as you know. Like I can have some very messy data set and then have, depending on the data set, how it is structured. So these steps vary. So as there are many characteristics and common symptoms of messy data which totally depend on the data used by the user for analysis. So this is a cleaning cycle of a data cleaning cycle, which involves importing data, exporting, normalizing, standardizing, rebuilding missing data, merging data sets. So these are some of the characteristics of clean data. Clean data in most cases is free of duplicates. It should be error-free. It should be relevant. The data has the appropriate data type for analysis should be, the data types have to be appropriate for analysis. For example, if you want to carry out a logistic regression, you have to make sure that your data is categorical in nature, and it has to be free of outliers, or only contain outliers that have been identified or understood. It should follow a tidy data structure. So these are some of the qualities of data, and there's relevance, accuracy, completeness, consistency, coherence, timeliness defined. So these are the common symptoms of messy data. Some data has special characters. For example, you have 2.5 and yet it was supposed to be 2.5. Numeric values stored as text or character data types. For example, you have a column of numbers of people's age stored as texts or strings. In most cases, messy data has duplicated rows. For example, you have to be with a unique record for each individual and yet you have like 2. Misspellings, inaccuracies, white space, missing data, zeros instead of null values, varia. So these are the useful commands in data cleaning, or some of the useful commands in data cleaning. For example, checking for missing values in the data set. For example, these are some of the common commands in case you're given a data set to make sense out of it. You might consider using call sums to list or to make summaries of the NAs in the data frame for each column, or use summary of the data frame. As you can see in the right hand side, I was trying to run a command to check for missing values in the data frame df, and it returns a column with with an output of missing values. Alternatively, you can check for missing values in a specific column, especially for numeric columns, by using maybe mean of the data frame, mean of a variable in a data frame. If it has missing values, it will return NA, as you can see in the second output, NA. Or if you do it without missing values by inserting an argument called NA.remove equals to true, you remove or ignore missing values. You can also check for irregularities in the data in the process of data cleaning. So we can get a clear visual of irregular data using a box plot. In most cases, a box plot checks for outliers. So in case you want to check for an outlier, you just say box plot df and then specify the variable name. As you can see in the picture above, in the right hand side, I was checking for outliers in credit amount. Yeah. So in case you want to do away with outliers, or if you want to replace them with median, you just run the command below that specifies the if else command. The code down there, the second last, and it will help you do away with outliers. So in the picture below, I was trying to show you how a sack of rice has unnecessary values, or that are completely different from rice. So we are trying to deal away with those irregularities in rice. So you can see we have white rice and then the one which is not rice and is unclean. So outliers are data points far from the data sets, other points. So this refers to data values dispersed among other data values and upsetting the dataset's general distribution. Like it distorts the distribution of the data. It doesn't approximate to a normal distribution. So outlier detection is a statistical approach used to find outliers in the dataset. So measurement errors, incorrect data entry, or really anomalous data values are just a few of the causes of outliers. So these are some of the effects of outliers in or on the model. So the format of the data appears to be skewed. If you have outliers, your data will always be skewed either to the right or to the left, which is called either positive skewness or negative skewness respectively. Outliers modify the mean, the variance, and other statistical characteristics of the data's overall distribution. This leads to the model's accuracy level being best. As you can see, the outlier in the picture above, some can be the smallest values, which are very few, and then some can be the largest values, which are very large, which are very few, I mean. So those ones become outliers. So let's see how we can detect outliers. First, we looked at the box plot. Then we are going to look at the histogram. You just have to run a command hist, then the data. In the command or in the picture above in the top right corner, you can see I ran hist df credit amount, and I was trying to check for outliers in the credit amount column. So these are some of the ways of removing outliers in the dataset. You can either use replace with a measure of central tendency as we saw here, like we were using an if else to replace with a median. Or you can use the interquartile range method to replace outliers. Here below is a picture of removing outliers from your data. Something like trying to verify that your theory is wrong. You outlier, we are trying to remove that liar. So let's look at data transformation. Data transformation in R is mostly handled by external packages like tidyverse, like tidy, and other packages like dplyr. And these packages provide many methods to carry out the data simulations. There are a large number of ways to simulate data transformation in R. And these methods are widely available using these packages. So we can download these packages or install them using command install.packages in brackets, then quotes, write the package name. So we are looking at the methods of data transformation in R. The first method would be arranging a data frame. So For data transformation in R, we will use the arrange method to create an order for the sequence of observations given. Yeah, this takes a single column or a set of columns as an input here to the method and creates an order for this. For example, in the picture above, if you want to sort by ID starting from the smallest to the largest, you would use the arrange method here. Or if you want to sort from the biggest to the smallest, you would still use the arrange method and specify if it's descending or ascending. So by default, it will arrange in ascending order. So the arrange method in the tidyverse package inputs a list of columns or column names to rearrange them in a specified order by default. Yeah, this works like the sort function in Excel. Yeah, so the syntax is you have to write arrange and in brackets write the column name of your data frame. Yeah, so you can also pipe, if you don't want to always call the variable name, you just pipe the arrange onto the df function. The other method is using the select. Yeah, like if you have a very big data set that has a number of columns and you want to select a few columns from it, you would use the select method. Yeah, so data transformation in R of the data frame can also be fetched using the select method in the tidyverse package. So the columns are fetched in the order of their specification. Yeah, in the argument list of the select method call. Yeah, so this method results in a subset of the data frame as the output. Yeah, so this is the syntax. You just have to load the library called tidyverse or dplyr, and then define a new data frame, yeah, and assign it to this function that is a pipe of other functions. Yeah, so I'll use data frame function, pipe it with the select function, and then inside the select, enter the variable names. Yeah, as you can see, I'm trying to select from a big data frame, only one column. Yeah, so a consecutive range of columns can also be fetched from the data frame by specifying the colon operator. For example, if you want to fetch from column 1 to column 5, you just write that column name, then full colons, and then write the other column that may be ahead, that is ahead, and this will take all the columns that are in between those two columns. You can also filter the data, like how you do the filters in Excel. You can also filter in R. Yeah. So the filter method in the tidyverse package is used to apply a range of constraints and conditions to the column values of the data frame in data transformation in R. So it filters the data and results in the smaller output returned by the column value specifying the specified condition, satisfying the specified condition. For example, if you have a data frame that has students' age and marks, and you want to to filter and take only students with age 12 and above or age 20 and above, you would use a filter method. Yeah. So the conditions are specified using the logic operators, and values are validated then. Yeah. So a data frame can be supplied with a pipe operator. Yeah. Then using the filter condition. So you would load your library, for example, dplyr or tidyverse, and then define a new data frame, then use the piping function on operator, on the data frame, and then write your filtering condition in the filter method. Yeah, you can also filter based on a vector of values in a specific column. For example, in column 3, and you can also filter based on maybe you want to filter out only people who are above 20 years and marks of 90 and above. Yeah. There's another method called spread. For example, you want to change your data from being a long data frame to a wide data frame, as you can see in that picture. So the data transformation in R spread method is used to spread any key value pair in multiple columns in the data frame. So it's used to increase the readability of the data specified in the data frame. The data is rearranged according to the list of columns in the spread method. Yeah, all the data in column 2, for example, is repeated until the columns in number 3 are exhausted. For example, here someone was trying to spread the data on the plot IDs. Yeah, on on the genus. Yeah. So below this is the syntax of how you can spread your data by first loading your tidy library and then use the piping operator to pipe a function called spread onto data frame and then spread column 3 over column 2. You can also mutate your data by using a mutate method. For example, if you want to create new columns on a specific data frame, you want to combine columns. Yeah, or you want to combine two data frames. Yeah, the data transformation in R, like mutate method, is used to create and modify new variables. Yeah, in the specified data frame. A new column name can be assigned to the data frame and evaluated to an expression where constants or column values can be used. For example, if you want to create a new column called column 5, which is a sum of column 1 and column 4, and column 6 is a sum of column 1 and a constant 1, you would use the mutate function, pipe it with the data frame object. You can also group or summarize, group by and the summarize method. They move hand in hand. Yeah. The data transformation in R, group by and summarize methods are used collectively to group by variables of the data frame, yeah, and reduce multiple values, yeah, down to a single value. For example, if you have a column that has weekday, Monday, Tuesday, blah blah, up to column 1000, up to row 1000, and you want to know how many of them were Monday, how many of them were Tuesday, so you would use the group by and summarize the counts. Yeah, so it's used to make data more readable. For example, making frequency tables. Yeah, the column name can be specified in R's group by method. So you can use the dplyr library and try to pipe the group by and the summarize functions on the data frame object. Yeah. So in the group by you pass in the column name, for example, column 3, and then in the summarize you pass in the functions of what you want to show for that specific column. For example, I want to show the count and then the mean or the average. There's also gather, the gather method. For example, you want to change your data from being wide to being long. Yeah. So many data columns indicate the values that should be stored in a single column of the data frame and are unnecessarily widely spread. So this can be done using the gather method. Yeah, it collects the key value pairs and rearranges them in new columns. Yeah, the column values are specified as arguments of the gather method. For instance, the following code snippet illustrates the combination of column 2 to column 4, yeah, of the data frame under argument 2 of that. So you can look at the syntax of what I've just said down here. Like I wanted from the mutated, I wanted to put things in a mutated data frame, yeah, by using the gather function, passing the subject max, then column 2 to 4. Thank you for watching. See you in the next video.